Now that we've talked about loops, I'd like to point out one place where sometimes people make a right-hand turn rather than a left-hand turn and get themselves into some conceptual trouble. And it takes a while to dig yourself out of this hole. To prevent you from even stepping foot in it, let me show you the problem. Sometimes you might think, well, hey, I have a while loop. I'll use that to produce animation. As long as the while loop is true, I'll draw a frame. So now I update some variables, the test is still true, I draw another frame, maybe some of my objects have moved. Now I update some variables, the test is true, I draw another frame. This is not the way to think about producing animation. In processing, we create each frame with a call to draw. When draw is finished, nothing in processing is even running until it's time to draw the next frame. Then draw wakes up, draws its picture, and it goes away again. In fact, this is very much like the way you might spend your days if all you had to do was draw pictures. You'd wake up in the morning when the alarm clock rang, you'd consult your list of things to do, and your job is draw a picture. So you draw the picture, and then you're done, and you go back to sleep and your day is finished. And this is your day until the alarm clock rings. The only continuity you have from one day to the next is the information you remember from one day to the next. And in processing, the way we remember that information is with global variables. The heart of the memory of your program is in your global variables. This also includes the global variables that processing manages for you, like frame count, width, and height. As far as your program is concerned, these are all global variables, and they represent your frame-to-frame memory. Conceptually, we call these the state. There is no real thing called a state. It's not a thing you create in processing. It's nothing you explicitly construct. But we think of the collection of global variables as the state. You can think of this as a synonym for status or configuration or long-term memory. The reason for having the state is so that when draw wakes up, it can consult the state, find out what it needs to draw, and then it draws the picture. Draw can also change some of the state variables if they're your own so that the next picture will be different. Of course, there's also the keyboard. The keyboard talks to the state. It reads the global variable key, and typically it will write one or more global variables of your own to remember what got pressed and make some changes in your program. In the same way, the mouse routines read the global variables mouse X, mouse Y, and mouse button, and they write new global variables so that your program can use the mouse information. I'll now show you a little animated piece that uses just two state variables, two floating point numbers that drives the whole thing. Here's the animation. Every frame is being created by a while loop. I'm drawing a bunch of nested circles and arcs that get smaller and smaller each time I go through the loop, and they all look like they're rotating, which is really just a little trick that I'll show you in a second. So the while loop starts with the biggest circle, works its way inwards, drawing smaller and smaller and smaller circles that look like they're rotating, and that's one frame. Here's the trick that makes this work. Right now I'm drawing an orange arc inside of a blue circle. So I can grab one end of the arc and kind of move it around, and I can grab the other end and move it around. And it's clear that I'm just adjusting one or the other ends of this arc. What if I now take the angle between the arc and fix it, so that if I move one end, the other end moves by the very same amount? So let's do that, and as I drag the arc around, it looks like the arc is rotating. It looks like I'm spinning this wedge of the pie. But of course, I'm not spinning anything. I'm not rotating anything. I'm just changing the angles of both the start and the end by the same amount. If I turn off the lock, I can move one end, I can move the other end. And then if I lock it in place again, now I'm changing both of them by the same amount, and again, it looks like it's spinning. That's the basic trick that makes this program work. Now let's see how I actually draw each frame. So here's the basic idea. I start with the background and I draw an orange circle. And then on top of that, I draw an arc that obscures half the circle. Here I've drawn it in dark blue so that you can see it. But in fact, in the program, what I actually draw is the arc in the background color. This makes it look like I've drawn a half circle. Now on top of this, I draw a new orange circle that's a little bit smaller than the last one. On top of that, I draw a blue arc, but of course it's the background color. Now on top of that, I draw a new orange circle, but on top of that, I draw a blue arc, which is the background color. And you can see I'm building up this nest of orange circles from which half has been removed into the background color. And it makes it look like I'm drawing a pattern of nested half rings. And that's really the whole trick. So let's see how to build up a frame. We start with the orange circle with its blue half circle drawn on top of it. And of course that blue circle would be the blue background. And I'll put a little dot in the middle so we can see it. Then the while loop runs. And I say while the radius is greater than 0, make it smaller and draw another circle. And I'll use slightly different colors just so we can see it, but all the oranges would be the same, all the blues would be the background color. Well, the while loop keeps running, I keep drawing smaller and smaller circles, and the half circles on top of them. Now I want to rotate the rings. Let's say I'm going to rotate them counterclockwise. So I'll draw the x-axis, I'll find some angle about which to make it look like I'm rotating the ring. Again, all I'm doing is changing the starting and ending angles of the blue arc. And now I have my little angle, and I'm going to call that angle start. That's the starting rotation that I apply to the outermost circle. So when I draw this, I draw the orange circle, and then I draw the blue arc at this angle. Now I'm going to work my way in. How much do I rotate the next circle? I could use the very same angle again, but for fun, I decided to use a second angle, which is a little bit different. In this case, it's a little bit larger. So that's how much I'm going to rotate the next circle in. I call that angle bump because I think of it as bumping up or making the angle bigger. So okay, I rotate the next circle in by that much. And then I keep using that same angle bump to rotate each circle, working my way in. And of course, I'm not really rotating the circles. I'm just drawing the blue arc using starting and ending angles that make it look like the circles are rotating. So that's a single frame. Of course, I don't draw it with the outlines, so we'll get rid of those. All the oranges get drawn with the same color, all the blues get drawn with the same color, and there's a frame from the animation. Later on, when I want to draw another frame, I start over again, I find angle start, except at the end of each frame, I make angle start a little bit bigger. And that makes the outermost ring appear to be spinning. So okay, I apply angle start, everything else would increment, but I also make angle bump bigger. And so now it looks like the inner rings are spinning faster and faster as time goes on. So I go ahead and I apply angle bump to each of the rings, working my way inward. And again, all I'm doing is changing the starting and ending angles of that blue arc. So it's all fake. It looks like I have these little discs that are spinning. I'm just drawing blue arcs. Here's the resulting frame. Get rid of the lines, make all the oranges the same, make all the blues the same, and we have a frame of animation. So really the whole animation is created as a series of frames, and every frame depends on only two numbers. Angle start, which tells me how much to rotate the very outermost ring, and angle bump, which tells me how much to rotate each ring working my way in. So this is the entire state of the program. As long as I know these two numbers, I can make a frame, and at the end of every frame, I make them a little bit bigger. Let's watch the program running again. So this is exactly what we just saw, but it looks more interesting. It looks like there's some complicated thing going on, and I love that. This is the kind of emergent pattern that can come out of just tinkering with things. The amount by which angle start and angle bump increment on every frame I found by trial and error. I started with some numbers I picked out of thin air, and then I made them bigger and smaller until the speed of this animation looked pleasing to me on my computer. I love the way these simple ideas can produce these really rich and interesting results. Each time draw is called, it looks at those global variables and uses them to produce a frame. And then typically it changes those variables a little bit. That way, the next time draw is called and it looks at those variables, the picture it creates is a little bit different than the one it created last time. Then it changes the variables again. Because the images are a little bit different from frame to frame, we perceive the result as motion or animation. As your programs get more and more complicated, you want to keep this picture in mind. This will help you avoid all kinds of problems, and you'll write code that's easier to design, easier to write, and easier to change later on when you get even more ideas.